Welcome to Strategies for Science, where we introduce strategies created by Mesquite ISD middle school science teachers in order to maximize time and learning for students. In this episode, we explain the lesson cycle. It was developed by Dr. Madeline Hunter, who came up with a set of steps that help teachers plan and deliver effective lessons. The lesson cycle can vary depending on the day's objective and students' needs. This video is intended to give you a framework for lesson design, but not every single lesson in your classroom will look exactly like this one. Remember, students learn in a variety of ways. Some lessons might have every component of the lesson cycle, while others might not. It's important to note that learning will look much different in classrooms conducting lab experiments or learning through inquiry. Let's watch one of our science instructional specialists, Matt Kane at Berry Middle School, show how he uses the lesson cycle in science class on a non-lab day. Mr. Kane always begins a lesson with the objective or purpose for the day in the first 5 minutes of class.
I put a lot of value into the first 5 and the last 5, and my kids know that. The first 5 minutes are very important to me because I think it just sets the tone for the rest of the day. I think one of the things we fall into, one of the traps we fall into as teachers is assuming that our kids know what we're doing for the day because we've done it 4 or 5 times that day, and so we walk in and we're ready to go. Well, they have no clue. This is the first time they're doing it. So we have to really set the tone for, hey, what are we doing today? What are we looking at? And what are we trying to accomplish when you walk out of here? Yesterday we focused on potential to kinetic energy, right? Yes. Transferring potential to kinetic. But here's the question. Is that the only way energy can transform? No, right? Now how do we know that? How do we know that's not the only way? Go ahead. There's more what? There's more types of energy, right? What a boring world it would be if the only type of energy we had was potential and kinetic, right? So we know there's other types of energy and other transformations, and that's what we're going to look at today.
The next part of the lesson cycle is the anticipatory set, or hook. The teacher focuses students' thoughts on what will be learned, tying in yesterday's lesson with today's. In today's hook, Mr. Kane shows a video, and then students answer the discussion questions he posted about in his Google Classroom.
Now, the next thing we're going to do, just watch this for a little bit, and I'll tell you what we're doing next. So I know that's kind of old school there, right? Several years ago, but it's okay. It's okay to bring back old stuff. Here's what I want you to do. Go to Google Classroom, and you'll see that there's a discussion question at the top of our stream, okay? And the discussion question says this: how do these videos relate to our physics discussions this week? All right? So let's not settle for basic answers. Let's try to use some academic vocabulary and really try to take the learning to a deeper level, okay? So an example, I had some kids in 5th period saying they're all moving. Well, that's true, but that's not using any of our academic vocabulary or concepts that we've learned. So the discussion question: how do these videos relate to our physics concepts, our physics discussions this week? As you're watching, and if something comes to mind, throw it on there, okay? I'm going to be looking at some of our responses here. What comes to mind? What physics concepts from our discussions this week come to mind as you watch this video? It's almost done. Did you submit something? Oh, good. Now y'all are coming in. Here we go. Good. Good. Okay, so let's have some people share out a little bit, okay? Go ahead, Jose. Okay, but what do we have to know if it's a balance force? Huh? You got to be a constant speed, right? So we don't really know their speed. Very good. But what else? That's okay. It's okay. There is a balance force at some point in there. What is it? Anybody know?
Me.
Go ahead.
When they're sitting still.
When they're sitting still, right? That is a balance force. So we do have evidence of a balance force. Good. Someone else. Give me another thing. I can see y'all's responses. Y'all know this. Don't be shy. Okay? Go ahead, Liz. Go ahead. Oh my gosh, what a beautiful answer. He says they all had potential energy, right? And some of you said this, you just don't want to say it out loud. They had potential energy, and then at one point, they transferred their energy from potential to what? Kinetic. Very good, right? So those videos, they're old, but they're relevant to what we're learning about right now. It's a transfer from potential energy to kinetic energy, okay?
The next part of the lesson cycle is called input. Input includes the information teachers want to impart to students in order for them to be successful. The new knowledge, process, or skill can be presented to the students in a variety of ways, including discovery, discussion, reading, listening, or observing. For today's lesson, Mr. Kane allows students to jot down all the types of energy they already know. Then they are given 2.5 minutes to walk around the room to discover new types of energy that they didn't write down. This is a great way to get students up and learning as an alternative to sit and get style note-taking.
Now with your group that you're sitting with, okay? With your group that you're sitting with, here's what I want you to do. I want you to list all the forms of energy that you already know about, okay? All the forms that you already know about. I'm going to give you a minute, so go ahead and have something to write with, a pen or a pencil, okay? All the forms that you already know about. Ready, go. 30 seconds. All the types of energy you already know about. I want you to do a quick walk around to all the blue papers, and if you see a type of energy that you didn't write down, I want you to add it to your list, okay? So all the blue papers around the room, ready, go. 2.5 minutes, go. If you have it, move on. If you don't, add it. If you don't have it, add it. One minute, 55 seconds. 1 minute and 55 seconds. If you don't have it, add it. There you go. It's okay. It's okay.
Elastic.
1 minute, 23 seconds.
The next part of the lesson cycle is called modeling. It is important for students to see what they are learning. It helps them when the teacher demonstrates what is to be learned. The teacher shows a graphic or demonstrates learning in a concrete way. In today's lesson, Mr. Kane placed labeled graphic representations around the room. Students were able to look at a picture that matched the new word that they were writing down. Then, Mr. Kane used hand gestures and explained those words to the whole class.
What were some of the ones that you originally didn't have, but you added after? Go ahead.
Electromagnetic.
Electromagnetic, okay? How many of you didn't have electromagnetic? Be honest. Yeah, okay. A lot of you. That's okay. That's one that we forget about a lot. Do you remember, does anyone remember what picture was next to electromagnetic? Very good. A microwave. Very good. A microwave. Okay. What's another one that you originally didn't have, Tori? Elastic potential,
Yeah.
right? So elastic potential is when we stretch things back. Now, as we stretch them back, what are we increasing? The potential energy. Very good. Elastic potential energy. All right, what's one more? Someone else that hasn't shared yet. What's one more? Go ahead. Huh? Gravitational potential, right? So we looked at the other day about how if I start raising an object up to a higher point, right? What am I increasing? The gravitational potential energy. Very good. Okay?
The next part of the lesson cycle is checking for understanding. It is important to make sure that students understand what was presented. One way this can be done is by asking students questions. The teacher uses a variety of strategies to determine student understanding, formatively assesses, and reflect on the pace of the lesson. In this step, teachers are thinking, should I move forward or back up? In today's lesson, Mr. Kane uses Nearpod to facilitate a formative assessment technique he calls Choose Wisely. Students will answer, and Mr. Kane will check for understanding to determine whether or not students are ready to move on to the next part of the lesson, or if he needs to adjust the pace of the lesson and reteach.
What are you going to do with that formative assessment? Because it's not just about having done it, but how is it adjusting your instruction moving forward? You're going to see a picture on the screen, okay? And you're going to label. Everyone's going to answer, okay? Everyone's going to answer. And instead of you choosing a card, just for time's sake, I went ahead and gave you a card. Okay? Now, you're gonna write the type of energy you see, the type of energy transformation you see. For every question, you're going to do it, okay? You don't have to write the full word. So if it's electrical, what could you do? EL, right? I don't need to see your spelling the full word. I just need to see your knowledge of it, okay? And then I'm going to come up here and spin, and if it lands on the card, the number you're holding, you're going to share out what you said, okay? So some of you are holding 4, 1, 2, 3, 5, right, 6, okay? Whatever it lands on, that person has to stand up and share out what they said. Let's see if you can remember. I will be so impressed if you can remember what form of energy is inside that. Go ahead. I think you just snatched his 4. Stand up, stand up, stand up, stand up, yes.
Chemical to mechanical.
Good, chemical to mechanical, good. What's the chemical energy? The ice cream, food, okay? Probably not the best choice of chemical energy, right? But nonetheless, it is a form for us, okay? Here we go. Next question. Here we go. Next question. Go ahead and label the type of energy transformation that you see. Write it above. Okay. Go ahead. Which one? Don't you know? Okay, that's gasoline, right? So gasoline to a car is what food is to us. Yeah, good. Chemical. Very good. Very good. Good. All right. Let's see who's going to... Hey, don't submit yet so that you can still see what you wrote. Okay? Let's see. Oh, you want to answer. Okay. Well, look what you got your wish. Go ahead, Jose. You called it. Stand up and deliver, dude. Chemical to mechanical. Good. As I was walking around, seeing a lot of you choosing that. Very good.
The next step of the lesson cycle is called guided practice. Students practice the new learning under direct teacher supervision. The teacher leads students through the steps necessary to perform the skill. In today's lesson, Mr. Kane sets up 2-minute stations. Students must complete a card sort and answer a question at each station in less than 2 minutes. They practice using new learning under his direct supervision.
All right, so here's what we're going to do next. Good. You have all the energy types now. So now you're going to do a little bit of practice with those. So pay attention for about 30 seconds, and then you're going to be able to move freely, and it's going to go smooth and beautifully, okay? At each station, you're going to be with your group that you played spoons with, okay? So you need to get back with that group, and you need to pick a station. At each station, there is a card sort, okay? You're going to have a minute to do the card sort, and then you're going to have a minute to complete the green FAM question, okay? Now, what do you think I mean by FAM?
Like
Force, acceleration, and not motion, mass, because those are the 3 things that we looked at the relationship between, right? So a minute to do the card sort, a minute to complete the FAM question, and then I'm going to rotate us to our next station, okay? Cool. 20 seconds before we rotate. Did y'all do the card sort? What you got? Chemical, good. Electrical, good. Sound, good. Good. Very good. Sounds from the buzzer, right? Good. All right, hey. Yeah. Click on the picture. What does it tell you it's doing?
strongly moves.
Okay, moving. Okay, good. Mechanical. So let's click mechanical. And then what's the point of this? What's the point of the mechanical? Yeah, but it's going to create what kind of energy? Look, click on it. Click on the picture. It turns a generator. What's it generating? Electrical. There we go. Electrical. Good. And then we use the electrical to dry our hair, right? I mean, I don't, but maybe y'all do. Okay. Is it chemical?
No.
What is it?
Thermal?
Thermal. Because what's that hair dryer generating? Heat. Good. So let's see. Let's check. All right. Good. Now go to the next one. Go to the next sentence. Yeah, chemical. So let's go ahead and let's find chemical.
I know this one's last.
Okay, so we know we got to start with chemical. Now, where's the thermal? What's the evidence of the thermal?
Fire.
The fire, the heat, right? Okay, good. And then what's the heat doing? We know heat rises, right? And what's it doing as it rises? Pushing what? What do we notice here? What's
Oh, is it moving?
Yeah, so there we go. All right, good. Mechanical. Very good. Now y'all hit the FAM question. Good, good, good. All right, so did y'all do the card sort? Or are y'all doing the question first?
Question first.
Okay, that's fine. So now let's look at this, okay? We're gonna look at where's the least kinetic energy, the greatest kinetic, right?
Yeah.
So let's put the cards where they belong.
Okay.
Okay, good. Greatest kinetic is at the,
Bottom. I forgot how to.
good.
The next step of the lesson cycle is called independent practice. When the teacher is sure the students understand the new material, they assign independent practice. The teacher releases students to practice on their own based on learning that has occurred during previous steps. Mr. Kane has provided differentiated Google Forms to students for this part of the lesson based on their needs. Some students will be simply determining types of energy, while other students who are ready to perform at a higher level will be identifying energy transformations. Students have no idea that their Google Forms are different. Differentiation is a way for teachers to meet students where they are and grow them from there, building confidence as new concepts are mastered.
Is there some differentiation that we can do? Today, when the kids did a Google form, it was not the same Google form for every kid. Certain kids had a level that's a little higher than some other kids. Some kids were just practicing identifying the energy transformation, and some kids were practicing just the types of energy, just with images that helped guide them in their thinking. And so, is there differentiation you can use? What form of energy transformation am I looking at? It starts with this energy, it ends with this energy. Maybe there's something in between. We're kind of just practicing the skill of looking at what is the energy transformation. Okay, so he's running, right? So what kind of energy if he's running? We don't want to say potential, because potential is when we're standing still. Stored energy. Which one of these is energy in motion? You don't know? It's okay. So here's the way I help kids remember it. Motion starts with what? What letter? M. Yeah, so mechanical and motion both start with that M, right? So that's an easy way to remember that mechanical is motion, all right? You do it? The Google form? Yeah. Yeah.
And finally, the last part of the lesson is called closure. The teacher reviews or wraps up the lesson by posing a question for the class. Closure is not an endpoint, but a final check for understanding used at the end of a class period. Mr. Kane poses the question, can energy be destroyed? He provides sentence stems to prompt students to write about their thinking.
And then the last 5 is very important because it kind of says, hey, you've done a lot during this 43 minutes. Let's kind of just press pause a little bit and really let's look at, hey, what did we learn today? What did we focus? Can we all walk out of here articulating exactly what we learned in class today? And so I would just encourage you, put a lot of value into that first 5 and last 5, because if you waste it, you're wasting 10 minutes a day. You do that 5 days a week, you're wasting 50 minutes a week if you just kind of don't care about the first 5 and last 5. So put a lot of value in that. Make sure the kids know where they're headed and make sure they can walk out of your room fully understanding exactly what y'all accomplished that day. Closing activity. Question. Okay? And think about it before you say anything. Can energy be destroyed? Don't shout out anything yet. Okay? Can energy be destroyed? Can energy, so here's some sentence stems for you if you need them. I think energy can be destroyed because, or I don't think energy can be destroyed because. So we always want to have a reason. We don't want to just throw out an answer. We want to be able to justify why we're thinking what we're thinking. I'm going to give you about another minute to write. And then I want 2 people to share out before we leave. We got 2 minutes of class left. Okay? Can energy be destroyed based on what we looked at today? And someone give me what you wrote or what you're thinking. You want to do it, Jose? Go ahead. What do you think?
I do not think energy can be destroyed because you're not going to be alive then.
Okay, so he says, I don't think energy can be destroyed because if it does, that scares you, right? Because we'll cease to live. Is that what you're saying? Okay. All right. Anybody else? Go ahead, Luis.
I don't think energy can be destroyed because if we didn't have energy, then we couldn't be doing stuff that we are doing today.
Okay, so he says, I don't think energy can be destroyed because we need energy to do stuff we do every single day. Go ahead.
And like, for example, mechanical energy, if we didn't have mechanical energy and it was destroyed, then we wouldn't be able to move.
Okay,
But we
good.
keep on going.
Tori?
I said I don't think energy can be destroyed, but only because I feel like it will always be there. Like sun gives us light and thermal energy, and I feel like the sun will be going in all the time soon.
Okay, good. Let's hope not, right? Good. Good. Last one.
I think some energy can be destroyed, like electric.
Okay?
Like windmills, since it generates electricity.
Yeah.
All we have to do is destroy it and we can make electricity.
All right, so hey, real quick before we leave, here's what you saw today. There's a law that says this. Energy cannot be, you maybe have heard it before. Energy cannot be, what? You know it? Created or destroyed, but it can be transformed, right? It can, and you saw that all over the place today, right? You saw energy going from one type to another, right? All right, y'all have a good day. We'll see y'all later.
To sum up, here is a list of the parts of the lesson cycle that Mr. Kane used. Objective, purpose, anticipatory set, hook, input, modeling, checking for understanding, guided practice, independent practice, and closure. It is important to note that this lesson took a lot of mental energy and planning time in the front end. Mr. Kane first did some research and ensured that the vocabulary and skills that were to be taught were all aligned to the TEKS. Then, he planned his lesson by putting the lesson cycle into 8-minute increments or less. He considered how students would get up and move, as well as how they would communicate and collaborate as they learned new information. He also incorporated formative assessment so that he could check for understanding and monitor pacing if needed. He incorporated differentiation in order to meet students' needs.
So one of the things that I really put a lot of value in as an educator is just the amount of effort that I put into my lessons. I hear teachers all the time talking about how chaotic their day was and how the kids were off task and how they don't care. And then you get to talking to them about their lesson and you can tell it doesn't really seem like you really cared a lot about your lesson either. One of the things that I live by is I'm never going to ask my kids to put more into a lesson than I've put into it. And so I really make an intentional effort to have every minute planned out and to think, how can I make this engaging? How can I get the kids moving? When it comes to planning, I like to kind of break everything into what does the next 8 minutes look like? What does the next 8 minutes look like? What does the next 8 minutes look like? I think that's just kind of an easy way to break up your planning. I think sometimes we sit down as teachers and we try to plan the whole day and we feel overwhelmed and we just kind of resort back to what's easy. But if you can just kind of break it into, hey, what does this 8 minutes of my class look like? So I think some good questions to ask and for how you're going to use those 8 minutes is, how am I getting my kids moving? How am I getting my kids talking? How am I getting my kids competing? If you can turn it into a competition, you're going to get the engagement from them. How am I getting my kids writing? How am I getting my kids thinking? If you can kind of answer those questions and then start to just plug in those 8 minutes at a time. You know, what can we do for these 8 minutes to get them moving? What can we do for these 8 minutes to get them talking? What can we do for this 8 minutes to get them thinking or competing or whatever it may be? I've just found that if you just plan it in those chunks of time, that the planning becomes easier and the day goes a lot smoother.
We hope you've enjoyed this extended version of Strategies for Science. Remember, teaching is an art and a science. And it is our hope that this video will give you a framework for lesson design. Remember, it is not intended to dictate how every single lesson should look in your classroom. That is up to you based on what your students need. If you have any questions, please contact your instructional coach or the science department. Thanks for watching.